Okay, we're solving the following three equations which involve logs, and if you notice with each of these equations they all have different bases, so we are going to have to apply the change of base rule for each of them. For part 1, so that has a base of 4 and that has a base of 2, so I would always change it to the base of the smaller number, unless there was another common factor between them, but anyway, 2 is the smallest, which means you can leave the right hand side alone and we're just going to change the base of this one. So again, to change the base in our log tables on page 21, this is the change the base rule. So if you've log x base b and you want to change it all to a base of a, you'll have a log with a base of a on top, log with a base of a underneath. The x goes on top and the b goes underneath. So applying that rule, I want to change log 3x plus 1 base 4 to have a base of 2. So I'll put log with a base of 2 above and below. Okay, then the 3x plus 1, that goes up on top, and the little 4 goes underneath. Now, if anything can simplify, then do it. Log 4 base 2, if you put that into your calculator, you'll get back at 2. So rather than leaving it as log 4 base 2, write it as 2 instead. So I've now gone from this term to now writing it with a base of 2. And I'm going to sub that back into my equation. So my equation will now read as log 3x plus 1 base 2 all over 2 is equal to the right-hand side. Now, I can answer this question a number of different ways. The initial method I would do is I'd get rid of the fractions. Okay, so if I get rid of the fractions, I would end up multiplying both sides by 2. So if you multiply this side by 2, the 2's would divide above and below. And if you multiply this side by 2, well then it's 2 times the log of x minus 1. Okay, so now at this stage, I would bring the 2 up and put it as the power of the bracket. So it would be log the bracket power of 2 base 2. Okay, when you have a log on both sides of the equation and they're both the same base, you can drop the logs at that stage if you want. Okay, and it's only because you have one log on one side and one log on the other side. So now you're just going to be left with 3x plus 1 is equal to x minus 1 to be squared. Now you just have an equation, normal quadratic equation. You need to multiply out that bracket, so square it out, so it's the bracket by the bracket. When you do that, you'll get these three terms. Bring everything to one side, so bring over the 3x and the 1 onto the right-hand side, and now the whole thing is equal to 0. Tidy it up, group-like terms, the 1's cancel. You're left with this quadratic, and you want to solve it. You can use your minus b formula to solve it, or the factorization method. Highest common factor is x, open a bracket, you're left with x minus 5 in the bracket. Therefore, either x is equal to 0, or the bracket is equal to 0. So x equal to 0 and x minus 5 equals 0, bring over the minus 5, add it on, you get 5. Now you have to check both solutions. If I sub x equaling 0 back into the original equation, the calculator will say error, which tells me then that the left-hand side doesn't equal the right-hand side. There's an error. X is not equal to 0. It doesn't make sense. Which means I'll check, is 5 a solution? So again, if you sub 5 back in up here, put it into your calculator, then do the same for the right-hand side, put it into your calculator, you'll see the left-hand side is equal to the right-hand side. So I then know that 5 is a solution. So that's the only answer for this question. Now, that was if I did it this method, okay, where I drop the logs. Let's say I don't want to do it that way. So at this stage, right, when we have fractions, if I don't want to get rid of the fraction, if that wasn't my first train of thought, division by 2 is the same as multiplication by a half. So you could just rewrite this term as a half of log 3x plus 1 base 2, okay? And then if you write it like that, you could bring the half up and put it as a power on the bracket instead, okay? Now at this stage, you have a log on both sides and they both are a base of 2, so you could drop the logs now. And then you're left with 3x plus 1 to the power of a half is equal to x minus 1. Okay, you need to get rid of the power of a half. Power of a half is the same as the square root of. So the opposite action of a power of a half would be a power of 2. Basically, if you put this to the power of the reciprocal of a fraction is the fraction upside down. So 1 over 2, the reciprocal will be 2 over 1. And what you do to one side, you must do to the other side. So I put both sides to the power of 2. A power of 2 will undo a power of a half. It's the reciprocal of it. So that would then just leave me with 3x plus 1 because you multiply the two powers and you get 1. Then this bracket is being squared. All right. So when you get as far as here, you are now back at the same stage you were when I did it this method. Okay, exact same equation. So you just do all the same working out to get out what x is. Okay. There's a third way I could have done it. So when I was back up at this stage, again, if your natural instinct would be to get rid of the fractions, multiply across by 2, and you got this equation. So that's where I am now. Okay. If you want, you could bring 2 log x minus 1 base 2. You could bring it over the equals, and then it would become minus 2 log of the bracket, all now equal to 0. Then you could bring the 2 up and put it on the power. And then at this stage, subtraction turns into division. So to be the log with a base of 2. This bracket divided by this bracket squared. Okay, all equal to 0. Nothing simplifies above and below here. Okay, so then just take it out of log format and write it in index notation instead. So to be 2 to the power 0 is equal to that expression. 2 to the power 0 is just 1. Okay, so now you have 1 is equal to that expression. Again, don't like fractions, so I'd multiply both sides by the common denominator, which is x minus 1 to be squared. Then that will divide into that, so it's gone. So you're left with 1 multiplied by that bracket squared is now just equal to 3x plus 1. Okay, and now again, you are now back to the stage that you were here, which is the exact same as that equation there. So you do all the same working out again. Okay, so that's question 15 part 1 solved. 15 part 2. They're in different bases again, so bring them all to the one base. I'd be inclined to go with whichever is the smaller of the two numbers, so I'll change it all to a base of 4. So that just means that one's fine. Change this one. So log x plus 1 base 5. Again, you're using the rule in the log tables. The change of base rule, how do you change it? You'll put the log with a base of 4 above and below. Then whatever's here goes on top, and that little base number there goes underneath. Okay, so you can see x plus 1 goes on top, and the 5 goes underneath. All right, now log 5 base 4, if you put that into your calculator, you do not get back a nice whole number. You get back a horrible looking decimal. In which case then, I actually wouldn't bother writing it as the decimal. Leave it in log format. It's easier because it doesn't simplify. So just leave it like that, okay? So now I'm replacing this with what I just turned it into, plus the log of that base 4 is all equal to 3. Again, my initial instinct would be get rid of the fractions. So the common denominator is this. So I'll multiply across by log 5 base 4. Okay, then simplify above and below. That will divide into that once, so it's gone. So then you're just left with 1 times the log of that, plus the log 5 base 4 multiplied by this is equal to 3 times the log of 5 base 4. Okay, now remember, log 5 base 4, it is just a constant. It's that big decimal on the calculator, okay? It's not a variable, right? It is a number. So I can apply the rule where I would bring the number up in front and put it on the power on the bracket. So now it will look like this. Okay, so it just looks complicated, but it's the same procedure as what I had been doing. And again, 3 times the log of 5 base 4, I'm leaving it in log format. There's no point in writing it as a decimal because it's not going to be a pretty number, okay? Right, at this stage now, I can apply my rule for addition of logs. Addition turns into multiplication. So to be the log of this bracket multiplied by that bracket to the power of log 5 base 4, all equal to 3 times the log of 5 base 4. Okay, now if you notice, the two brackets are the same. Like they have the same variables inside them, x plus 1. That bracket is to the power of 1. So given that this base number is the same as this base number and they're being multiplied, you can apply rules of indices and add the two powers. Okay, and then you'll get a power of 1 plus log 5 base 4. Okay, so now at this stage, you have log, this bracket to the power of that, base 4 is equal to the right-hand side. So now we can just take it out of log notation. 4 to the power of this is equal to that expression. Okay, so 4 to the power of 3 log 5 base 4 is equal to that. Now, that's just going to be some decimal on the calculator if you put it in. I'm going to leave it as it is for a second, okay? I want to get x on its own, but x is trapped inside the bracket. So the only way to get rid of the power, so that you can get just x plus 1 on its own, is if you put the right-hand side to the power of the reciprocal of its fraction here. So 1 plus log 5 base 4, put that over a 1 as a fraction. So in order to turn that fraction into a 1, you'd have to multiply it by its reciprocal. The reciprocal is just the fraction turned upside down. So it'd be 1 over 1 plus log 5 base 4. That's the reciprocal of that fraction. Because now a power to a power means you multiply them. And if you multiply a fraction by its reciprocal, you'll get a power of 1, which means the power is gone, right? But if I do it to this side of the equation, I have to do it to that side as well to keep the equation balanced. So I'm now putting this side as well to the power of, 1 plus log 5 base 4. Okay, so I've done the same thing to both sides in order to get rid of that power. Put it to the power of its reciprocal. Okay, so now you're just left with x plus 1 is equal to this ugly looking thing, but it's still just a number. Bring over the 1 and subtract it to get x on its own, and then you can put all of that into your calculator. Okay, so 4 to the power of that to the power of that is 9.3402. Bring over the 1 and subtract it, which means your final answer is 8.3402511781. And unless you are asked to round it, don't. Now I would check if that's correct. So I will keep that answer on my calculator and I'll sub it back into the original equation, back up here. So where you have an x, replace it with the answer you just got. Press equals and you should get back 3. That is correct. Okay, now that's one way to solve it. The other way to solve it, so if I come back to this stage, right, where we had it as the log of this plus the log 5 base 4 of this, because we had multiplied across by the denominator, and we got this equation. Instead of doing what I did next, I could have done this instead. If you notice, that bracket is the exact same as that bracket. That tells me that these two log terms are like terms. Do you know, it's like grouping the a's together or grouping the b's together. I can group the log x plus 1's together. There is a 1 in front of that log. There is a log 5 base 4 in front of that one. So given that they are like terms, I can just add the 1 with the log 5 base 4 and write it as 1 plus log 5 base 4 times log x plus 1 base 4. So I just grouped the like terms, okay? If that was a lovely number like 6, then it would be 1 plus 6, which is 7 log x plus 1 base 4, right? It's just not a nice number, but it's still just a constant. And all of that equals 3 log 5 base 4. Okay. I eventually want to solve for x. X is attached onto the log, so I need to get rid of what's in front of the log. It's being multiplied, so I just divide, and what you do to one side, you do to the other side. So I'm going to divide across by 1 plus log 5 base 4, and if I do to that side, I have to do to the other to keep the equation balanced. Okay, so that's all I've done here, divided both sides. So then that will divide into that one, so it's gone. So you're literally now just left with log x plus 1 base 4, which is what I have here. And that equals the right-hand side, which is a big decimal, if you put it into your calculator. Last step, I want to get it out of log notation. So it'll be 4 to the power of this is equal to that little expression. Okay, so 4 to the power of that is equal to x plus 1. Bring the 1 over and subtract it. Put it into the calculator, so it's all of that, take away 1, which gives me my 8.3402. That's the exact same answer I got when I did it this way instead. Okay. There is another way of doing it. So when I went back up to the original equation, this was the original equation. Before I go multiplying across by the common denominator, if I don't want to do it that way, I can do it this way instead. Division by log 5 base 4 will be the same as multiplying the numerator by 1 over log 5 base 4. You're just separating out the denominator and writing it as a fraction, 1 over. Okay, so this term is the exact same as that term. It's just manipulated a little bit. So now at this stage, you could bring that number up and put it on the power of the bracket. Because again, that is just a constant. It's just an ugly looking constant, but it is just a constant if you put it into your calculator. It's a decimal. So I bring it up and put it on the power on the brackets, and now it looks like this. My logs are both in a base of 4. Okay. Addition turns into multiplication. So now it's going to be the log of this bracket to the power of that, multiplied by that bracket, which would be to the power of 1, all equal to 3. Because the brackets are identical, x plus 1, I can apply rules of indices. You can add the powers. Okay, so then you'd get a power of 1 over log 5 base 4 plus 1, all now equal to 3. Take it out of log format, so it'll be 4 to the power of 3 is equal to that expression. Okay, now I eventually want to get x on its own. X is inside the bracket and the bracket is being put to this power. Now, naturally, when you want to get rid of the power, you want to turn it into a 1. You'd have to put it to the power of its reciprocal. Now, I can't get the reciprocal of this so far because that's not one individual fraction. That is 2 fractions. So what I need to do next is I need to write that power as a single fraction next. Because then once I have it as a single fraction, I can write the reciprocal of it. So over here, I've written that as a single fraction. Common denominator is log 5 base 4. Log 5 base 4 into log 5 base 4 goes once, then it's 1 multiplied by what's on top, which is a 1. Bring down your sign, plus 1 divides into log 5 base 4, log 5 base 4 times, multiplied by what's on top, which is a 1. Tidy up the numerator, you're going to get 1 plus log 5 base 4 all over log 5 base 4. So I have now written those two single fractions, I've written them as one single fraction, and I'll now replace that back into my equation. So now my equation looks like this, and 4 cubed is 64. So now I want to get the bracket on its own. So what I do now is I put this side to the power of the reciprocal of that fraction. Flip that fraction upside down and it would be log 5 base 4 all over 1 plus log 5 base 4. That is the reciprocal of that fraction. Because then a power to a power means you'd multiply them. If you multiply a fraction by its reciprocal, you will always get back a 1. If I do it to this side, I have to do it to that side as well. Okay? So now I'm left with x plus 1 is equal to the left-hand side. Bring over the 1 and subtract it to get x on its own. And then you can put it into your calculator. So it'll be 64 to the power of this. Take away 1 and you get your 8.3402. That is the exact same answer when I did it the other two methods as well. So there's always more than one way to solve a log equation. It just depends on what way you go. And my natural instinct always would be to get rid of fractions first and then see what you're working with after that. Part 4, solve. Again, we're in two different bases. So I need to change it all to the same base. I'm going to bring it all to a base of 2 because 2 is smaller than 3. That's just a rule of thumb. It doesn't actually matter what base you bring them to. So then I only have to change this one. So I'm writing log x base 3 as a base of 2. So again, x will go on top and the little 3 will go underneath. Again, like the last example, or like the last question, log 3 base 2, if you put it on your calculator, you'll get back a decimal. Which means I'm not going to write it in decimal format, I'm going to leave it in log format. And I'm now going to replace that in my equation. So now my equation reads like this. My initial instinct would be to get rid of the fractions. So that means multiply across by the lowest common denominator. Okay, simplify then above and below where you can. And now your equation will read like this. Next step, I would bring the, well, you can do it loads of different ways. You could bring this up and put it as the power of the x, or if you want, look at the two terms. That's a log x base 2, that's a log x base 2. They are like terms. So in which case there is a 1 in front of that. So you could just say, right, well, log 3 base 2 plus 1 is log 3 base 2 plus 1 times log x base 2. So again, it's like if that was a nice whole number, if that was like a 5, then you'd say, right, well, they're like terms. So it'd be 5 log x base 2 plus 1 log x base 2 would give you 6 log x base 2 if that was the case. So just because it looks like an ugly looking constant, it's still treated the same. All right. I want to get x eventually on its own. X is attached onto the log, so I need to get rid of this bracket. So divide across by that bracket on both sides, and when you do that, you'll get this equation. You'll have log x base 2 is equal to the right-hand side. You could put that into your calculator if you want. It'll just be a horrible looking decimal, which is grand, but I'll leave it as it is for the moment. The next step, take it out of log notation. So it'll be 2 to the power of this expression equals this expression. Okay? And now you have x on its own. So put all of that into your calculator and you'll get back 1.529 or 5295 goes on forever. Sub that back into your original equation to see will the left-hand side equal 1, and it will. Okay, so that was one way of doing it, but if you don't cop that they are like terms, you don't have to do it that way. I'll do it this way instead. When you were at this stage, you got rid of the fractions. I would bring the power, that number, bring it up and put it as the power on x. So now it will look like this. Okay? Then I would use my rule for addition. Addition turns into multiplication. So it'll be the log with a base of 2. This term multiplied by that term. And x on its own is x to the power of 1. Now remember, they are like terms, so I can add their powers using rules of indices. And I'll get a power of log 3 base 2 plus 1. Okay, next step, you want to take it out of logs. Or you could drop the log. You could, because you have a log on this side and a log on that side, you could actually just drop the logs and you'd get x to the power of that equals 3 if you want, because you're going to get that anyway in a second. Alternatively, take it out of log notation, it would be 2 to the power of that equals this expression. Okay, so 2 to the power of that equals x to the power of that. I want to get x on its own. Again, in order to get that as x to the power of 1, you need to put that to the power of its reciprocal. So log 3 base 2 plus 1 as a fraction is over 1. Well, then the reciprocal, flip it upside down. Okay, and what you do to one side, you do to the other. So power to a power means you multiply. If you multiply a fraction by its reciprocal, you'll get a power of 1. Then you can throw all of that left-hand side into the calculator and you get back 1.592. Or sorry, 1.5295. Goes on forever. That's the exact same answer I got when I did it the other method. Okay, even at this stage, if you had decided to drop the logs, you'd be left with x to the power of that equals 3. So it would look like that. X to the power of that equals 3. Then you want to get x on its own. So you would have to put this side to the power of the reciprocal of that fraction. That fraction is over 1. The reciprocal would then be 1 over log 3 base 2 plus 1. And what you do to one side, you do to the other side. You will then get left with x equals. Put that into your calculator, 3 to the power of that, and you will get back 1.5295, goes on forever. So I get the exact same answer, okay, if I had gone with dropping the logs at that stage. But I can only do it if you have one log on one side, one log on the other side, and they were both to the same base. A fourth way of solving it, if you didn't bother multiplying across by the denominator to get rid of the fraction, you could have pulled out division by log 3 base 2 is the same as multiplication by 1 over log 3 base 2. So you could have just pulled it out, separate that term out. Then you can bring that up and put it on the power, so it looks like this. Then addition turns into multiplication rule. Then it's rules of indices because you have an x to the power of 1 multiplied by an x to the power of that, which means you can add the powers to get x to the power of this. Take it out of log notation next, 2 to the power of 1 equals that expression. 2 to the power of 1 is just 2. Okay. In order to get x on its own, I'd have to put this side to the power of its reciprocal. But that's not one fraction. That is 2 single fractions. So I'd have to go and write that as one single fraction first with a common denominator, and eventually it'll look like this. I can then sub that back into my power, so now it looks like that. And now I'd be able to write that as a reciprocal. And what you do to one side, you must do to the other. So power to a power, you multiply them, you'll get a power of 1. So x is now equal to the left-hand side, put 2 to the power of that into your calculator, and you'll get out your 1.529. So again, it's a fourth way of doing the exact same equation, and I'm getting the same answer regardless. All right, so that is question 15, parts 1, 2, and 4.